Welcome to our program, Astronomy for Everyone. The topic for this month's show is questions from our viewers. The emails that we've received here at Astronomy for Everyone, we've gone through and picked what we thought were the most interesting. Our questions are going to be asked by my colleague here at Astronomy for Everyone, Ken Anderson. Ken, welcome back to this side of the camera.
Glad to be here.
All right, well, let's get started. Ken, what's the first question from our viewer?
Okay, the first question is, I'm interested in buying a telescope, but I don't know which one to get. Is one better than the other?
Well, the short answer is no. The real answer to that question is, what do you want to do with the scope? Now, there are two basic types, a refractor, which is a lens, or the reflector, which uses a mirror. So it's basically a lens versus mirror question. As far as cost, we all don't have limitless pocketbooks, so cost is usually one of the factors involved. And inch for inch, the mirror or the reflecting telescope does cost less. Now, as far as the use you want to put them to, for doing planetary or observing double stars, the refractor, the lens-type telescope, would be the better choice. However, if you want to go after deep sky objects such as nebula, galaxies, and star clusters, you're better off using the reflecting type because with this you can get more aperture, a little bit more bang for your buck, if you will. You'll be able to gather more light, and in that way the object you're looking at is going to be brighter. So again, cost being an issue, also portability, depending on your physical limitations, if you have any, a larger or smaller scope, something that you're able to carry around. And then of course, depending upon the types of objects you would like to look at, you can look at all the objects with either scope, but breaking it down in the way I just mentioned probably would work out better. But the best scope to have, well, it's the scope you use most. All right, Ken, what's our next question, please?
Okay, the second question is, explain the difference between waxing and waning when talking about the moon.
Good question. When you hear the term waxing moon, it has nothing to do with Simonizing your car, okay? The term waxing actually comes from the old German word wachsen, which meant to increase. So a waxing moon is a moon that's appearing to get bigger and bigger from night to night as we move from new moon up to full. Now, typically you hear the term waxing and waning to describe the gibbous phase of the moon. The gibbous phase is the waxing part is between first quarter and full, and then the waning gibbous would be between full and third or last quarter. Now, the thing to keep in mind is that one half of the moon is always lit up by the sun. What makes a difference is where the moon is in regards to its orbit around the Earth. And a great experiment to do to kind of help prove this to yourself would be to have a lamp without a shade on it, yourself, and a ball, say a softball or maybe even a volleyball. And start out with this experiment with holding the ball out in front of you. The lamp would be beyond you. And then just start turning around, making a 360-degree circle with the ball still held out in front of you. And you'll watch the ball go through the same phases of the moon that we see in the sky. It's really an interesting experiment to do. It's great to have the kids do it to help them understand why we see these different phases at different times of the month. And put a final touch on that question. The moon does rotate on its axis. That's why we always see the same face facing towards us. If it didn't, we would see the other side of the moon. But the moon rotates on its axis at exactly the same speed that it orbits the Earth, and so that's what always keeps the same face towards us. All right, Ken, our next question.
Next question is, Is it warmer in the summertime because the sun is closer to the Earth that time of year?
Great question. I've gotten this question in my work at the Michigan Science Center working in the planetarium, and it would seem intuitive. By that I mean, if you walk closer to a campfire, you get warmer, and if you back away from the campfire, you feel colder. Well, with the seasons, that's not the case. What the real cause for the seasons is the tilt of the Earth's axis. Okay, the Earth is tilted at 23.5 degrees. All of us, I'm sure, remember that globe that sat on the teacher's desk that had the angle like this. That represents the true pitch of the Earth in regards to the plane of its orbit. And it's that angle is what's responsible for the seasons. Now, this angle is always in the same direction. It's always aimed like this. So if this is the sun and this is the Earth and the northern hemisphere is up here, our hemisphere is aimed more directly at the sun. But 6 months later, well, that angle's still the same, but now North America's tipped away. The energy is not as direct. Another great experiment to do at home would be to take a flashlight, turn it on, aim it straight down at, say, a table. See how bright that light is. Turn it off for a second, and then set the flashlight at an angle. Turn it back on. You'll notice that that beam of light isn't as bright. The first part of the experiment would represent summer. Okay, the energy of the sun, or in this case the flashlight, is more direct, it's more concentrated. But with the winter, that same amount of energy is spread out over a larger area, and so because it isn't as concentrated, it doesn't get as warm. The Earth varies in its distance from the sun. The average is 93 million. It varies between 91 and 95. And people are surprised to find out that the Earth is actually closer to the sun in early January and at its furthest point in early July. So the distance has no effect whatsoever on what makes it hot in the summer and cold during the winter. All right, Ken, do we have another question, please?
Yes, we do. And also, if you look at the sun and its position at noon, in the summertime, the sun is higher in the sky than in the wintertime at noon.
Exactly.
Okay. The fourth question we have from the viewers is, what are the rings of Saturn made of, and are they solid?
Yes. Another question from the folks at the Science Center. No, the rings are not solid. They're made up of chunks of ice and rock, debris basically. These chunks range in size from houses and school buses down to driveway gravel and even grains of table salt. And all of this rocky and icy debris is held in place by gravity, surprisingly. It's the gravity of both Saturn and the gravity of small moons that orbit within that rock and ice. They're called shepherd moons, and they're scattered all around the rings. And it's the combined gravity of those small moons, those shepherd moons, and the gravity of the planet itself that holds them all together. So while it may look in a photograph, or even if you have a chance to look through a telescope to see the rings of Saturn, they may appear solid. In fact, they are not. So hopefully that clarifies that question for you if you ever wondered about that. We're going to take a quick break right now. If you have any questions or would like to actually get some more information, you can visit our website. You can always go to the website. The address is down there at the bottom of your screen. And after Term of the Month with Stephen Whitty, we'll be back with more questions from our viewers.
The term of the month for January 2015 is Great Red Spot. And what we're talking about is the Great Red Spot on Jupiter. Now, the Great Red Spot was observed first in the mid-1600s, so it has been a storm on Jupiter since then. Probably since before then, but that's when we first knew about it. You really needed a telescope to see it. Galileo had his telescope first pointed to Jupiter around 1610, so it was sometime after that before people actually noticed it. The color changes on the Great Red Spot from dark salmon to white. And when it's lighter, when it's closer to white, it's much harder to spot. You need a bigger telescope with more light, and etc. Now, what is the Great Red Spot? It is a storm. So you could think of it as a hurricane, except that several Earths would fit across this hurricane. It's absolutely enormous. But unlike storms on Earth, which only last a few weeks, and they are low pressure areas, the Great Red Spot on Jupiter is a high pressure area. So it rotates and it roils and does all of that interesting things. Now, up until relatively recently, it was thought that the thing that made the Great Red Spot red was phosphine. And the thought was that if you get phosphine dredged up from deep within Jupiter, that if you exposed it to sunlight, then it would turn into a hydrosulfide-like material by the sunlight, and that would be red. But when you take phosphine and you expose it to ultraviolet light to simulate the sun, in the lab it turns green, not red, so it's just simply not phosphine. But recently, scientists mixed ammonia, which is known to be in the atmosphere of Jupiter, and acetylene, also in Jupiter's atmosphere, and they exposed that to ultraviolet light, and it made a cyanide or a set of cyanide-like chemicals, and it turns out that it's red when you expose it. And it's red because it absorbs blue light. Now, the Great Red Spot keeps this material confined into one spot, and also it raises it above the other cloud decks, and so this material has time to become red. The Great Red Spot, the term of the month, January 2015.
Thanks, Stephen, and welcome back to the second half of our show. We've got another series of questions from our viewers, folks much like yourself. With me in the studio again is Ken Anderson, our colleague here at Astronomy For Everyone, who is asking me the questions. All right, Ken, what's the next question, please?
The first question we have from the viewers is, do other stars have planets like our sun?
All right. Yes, they do. This, though, is a fairly recent phenomenon that we've been able to discover. By that I mean since about the mid-1990s. At that time, the first extrasolar planet, that means a planet that circles a star that isn't our sun. They're called exoplanets, is the short term, to separate them or not confuse them with the planets of our own solar system. This planet was discovered around a star in the constellation of Pegasus, the winged horse. And about a year later, the second and third one were discovered by Americans, by the way. The first one was discovered by some Swiss astronomers. The second and third ones were found, the second one in the constellation of Virgo, and the other one in the Big Dipper. Now, since the mid-90s, hundreds and hundreds of these exoplanets have been discovered. Most of them are in the range of a Jupiter-sized planet, so they're, we feel, gas giant planets. To be that big, they're probably constructed of gas. We have found some super Earths, planets that are rocky or terrestrial in nature, like the Earth, but they're 3 to 4 times bigger than our home planet. Now, the technique used to discover these planets is called the transit method. In other words, they look to see if a planet travels across the face of its parent star, lines up with us as seen from here on Earth, and then through further investigation, they determine if it was a planet or some other object crossing in front. They usually like to wait to see if there's a couple of transits to really make a determination if it is, in fact, a planet. Now, because of that technique that's used, it's very difficult to try to find an Earth-sized planet. They're so far away that to try and find them visually is virtually impossible. So perhaps in the coming years or decades, they'll come upon a little bit better technique that might help us find a more Earth-like planet. Now, one of the other things they do besides actually finding these planets and determining their size and composition is to find out if they're in the habitable zone. In other words, a region where liquid water could exist, which we feel is one of the primary requisites for life, at least as we know it. The fun term used for the habitable zone is actually the Goldilocks zone, right? From the story, not too hot, not too cold, just right. All right, Ken, our next question, please.
Next question is astrology and astronomy the same thing?
Absolutely not. Astrology is a belief system. Astronomy is a science. Now, for thousands of years, astrology and astronomy did go hand in hand. Objects up in the heavens, celestial objects such as those wandering stars, as the Greeks called them, planetae, which we call planets, were given godlike qualities. People looked to the heavens for guidance and felt that events and lives here on Earth were controlled by those deities up in space. And this held true, as I said, for many thousands of years. That is, until about the 16th century, with the arrival of such scientists as Copernicus and Galileo. Their studies started to show them that these qualities given to these celestial bodies really wasn't the case. There was a rational explanation for these phenomena and for these objects. And moving forward from them, you had people such as Kepler and Sir Isaac Newton, who further helped separate astrology from astronomy. Astronomy is a science, astrology a pseudoscience. Now, it's fun to look at it, I guess, and if you want to, that's quite entirely up to you. One person who was into astrology quite a bit was also a great composer, was Gustav Holst, who wrote the Planets Suite. There's some great imagery in that music, and because the music is so great, we'll forgive him his dabbling in astrology. If you'd like to read more about that, you could get the book by Dr. Phil Plait, Bad Astronomy. He does a nice write-up in that book. All right, Ken.
I kind of consider astrology and horoscopes more a culture. You know.
Or a cult, yeah,
Yeah.
that type of thing. All right, what do we got next?
The next question is, what type of telescopes are in observatories?
Okay, well, when they first started out, you would find the refracting telescope, the telescope with lenses. Later on, reflecting telescopes, the mirrored type, were built, again, because you could get a greater aperture. You could collect more light, and so distant objects were brighter. Now, they tried casting these mirrors as one huge piece, and beyond a certain point, it just became impossible to do so. So they came up with the segmented reflecting mirror. In other words, smaller segments joined together that would act as one large mirror when put together. Now, these are included in a lot of different observatories, which today are typically built on the tops of mountains, such as Mauna Kea in Hawaii, in Chile, in the mountains high above the Atacama Desert, and also in the Canary Islands in the Atlantic. Now, there are also other observatories, but they're up in space. The Hubble Space Telescope is one, and the Chandra X-ray Observatory is another. Observatories that don't require buildings at all, well, those are radio telescopes, which we can find in Puerto Rico, West Virginia, and also in New Mexico. Okay, Ken, do we have another question?
Yes, the last one is, how do I become an astronomer?
Well, for that, you need to study your sciences, your mathematics, take a heavy science-based curriculum, and really decide what area of astronomy you would like to work in. There are a number of different areas, people who do visual observing, though today that's typically done in front of a computer screen. There are others that design astronomy equipment, and really there's a number of other areas, right, Ken?
That's true. You can do research in astronomy, you can do visual, you can take imagings in astronomy.
Now, to be an amateur astronomer, all you need to do is have curiosity, a wonder of the night sky. Best way to do that would be to join an astronomy club, such as Ken and I have been doing for years. You can be with like-minded people who share a similar interest. We help educate each other. And you can also go to star parties sponsored by these astronomy clubs to look through various types of telescopes to help you decide which type you would like to purchase. Or maybe you'd like to purchase a pair of binoculars to do astronomy in that way. Either way, astronomy is a great subject, and we hope very much, if you have any interest, that you would pursue it, especially if your children show an interest in it.
And a good way to do that is to find out if there's a local astronomy club in your area, and you also have astronomy magazines that you can go by and learn a little bit about it.
Exactly. We hope you've enjoyed this questions from our viewers. If you would like to have your question read on a future show, send us an email, please. You can see the email address down at the bottom of your screen. And coming up next is Stephen Whitty with What's Up in the Night Sky for January. Thanks for watching. We'll see you next time.
What's up in the night sky for January 2015? The month has the Earth closest to the Sun on January 4th, and you would think that that would make it warm in the northern hemisphere, but no, it's winter. So, at the very beginning of the month, the Sun rises at 8:02 in the morning and sets at 5:11 p.m. By the end of the month, the Sun rises a little earlier at 7:47 a.m., but it sets quite a bit later at 5:46 p.m. So the days are getting longer, even though we just had the shortest day of the year in late December. The full moon is on the 4th of January, which is also basically the day when the Earth is closest to the Sun, the third or the fourth most years. On the 13th, we have the third quarter moon. On the 20th, we have the new moon, which you shouldn't see. And on the 26th, we have the first quarter again. I like the first quarter, it's up in the evening. I like the third quarter, it's up after midnight. I like the new moon because you can see other things other than the moon, and everybody likes a full moon, right? Mercury and Venus are very close together on the 10th of January. They're very, very close. You can see the little arc there that is the orbit of Mercury, and this on the 10th, Mercury is about as far away from the Sun as you can get. Mercury sets at 6:55 p.m., which isn't that long after sunset. It's best on the 15th of January, where the shot is actually at 6 p.m. here. Venus sets, if we could go to Venus, Venus sets at 6:58 p.m., just a hair later after Mercury, they're so close together. Venus is better later in the month. In fact, it is, here it is on the 31st at 7 p.m. It is better later in the month, and what I mean by later is not just later in the month, but later all the way into June. Venus gets as far away from the Sun as it will get in this orbit. Mars sets at 8:30 p.m. So it's setting a little after Mercury and Venus. In the next image, this is Mars on January 15th at 8 p.m. With the Moon. It happens to be near the Moon. So you can see Venus setting ahead of it. Uranus and Neptune are then further above Mars. So Mars sets shortly after that. Neptune sets. Now Neptune is so faint that it's really not possible to see that without a telescope or fairly decent binoculars. So Mars sets, Neptune sets. You need a decent sky chart, even though it's very close to Mars. You still need a decent sky chart to see Neptune. So this is an image on January 15th. Neptune sets at 8:45 p.m. Uranus then sets at 11:55 p.m. So here we are seeing Uranus and Neptune at 8 p.m. on the 15th. Jupiter rises at 7:25 p.m. So shortly after it rises, which is really right around when the Sun sets. So that's in the east. Here we're looking at Jupiter near the Moon on January 7th at 8 p.m. But you'll be able to see Jupiter most of the night, all month. So that you don't really need the Moon to find Jupiter. Jupiter is really quite bright. But I just thought I would throw that in. Saturn rises at 4:08 in the morning. So I find it's, Saturn sets at 4:08 in the morning. Here it is on January 31st at 11 p.m. So Saturn is partway through the sky, and so it's more toward the south. Now, if we roll back to that January 4th, where we had the full moon and we had the Earth closest to the Sun for the year, we also have a meteor shower, the Quadrantids. Now, the Quadrantids are named after an obsolete constellation. The constellation is really up in the north by the Big Dipper. Today, the constellation area has been renamed to be part of other constellations, Boötes and Ursa Major. So the Quadrantids can be really, really a spectacular show. The peak is very brief, though, and catching it is tricky at best. And meteor showers, since the meteors themselves come from comets, they're really quite unpredictable as to exactly when they'll show up and how bright they'll be and so on. But we expect the Quadrantids to be up on the evening of the 3rd and morning of the 4th. But with the full moon, they may wash some of them out. Some years, the Quadrantids show 100 meteors an hour, really awesome. So that is what's up in the night sky for January 2015. Keep looking up for the greatest free show over your head every single night. See you next time.